The top side of a typical system board, such as the PCIe card shown here, is populated with FPGAs, ASICs, microprocessors, transceivers, memory ICs, connectors, and DC-DC regulators. Increasingly, physical space comes at a premium. The backside of the board is often subject to severe height restrictions, making component placement there impossible. Industry standard practice often allows topside devices to reach a few centimeters in height, but limits backside packages to less than 2.3 millimeters. To facilitate miniaturization, it becomes clear some functions historically found on the top side of the board need to move to the bottom. Analog Devices' ultra-thin product line of micromodule DC-DC regulators address this emerging market. We have a new member of the ultra-thin family, and it packs a real punch. It features an I2C based PM bus interface for digital configurability and monitoring of the power supply. Hi, my name is Jason Secanina. I'm a design engineer of micromodule power products here at Analog Devices. And today I want to tell you about the LTM4686. At only 1.82 millimeters tall, the LTM4686 is a new addition to the ultra-thin micromodule DC-DC product line. Featuring a PM bus interface, the LTM4686 is also a new addition to our Power System Management PSM micromodule DC-DC product line. The LTM4686 is a dual 10-amp DC-DC regulator capable of 12 amps per channel peak transiently. Here's our portfolio of ultra-thin modules. 1.82 and 1.91 millimeter are standard package heights for ultra-thins. Look at the side view of the package. As you can see, these modules are just slightly taller than 1206 size ceramic capacitors, making them well suited for bottom side board placement. Of the modules shown, the LTM4686 is unique in this family, featuring a PM bus interface. Designing in modules is your fastest path to uncluttering your board and making room for your proprietary chipsets and value-add features. The LTM4686 contains power inductors, power MOSFETs, and a dual controller IC with PM bus interface along with supporting components. Highlighted here are example normal height DC-DC regulators that were historically topside mounted due to mechanical constraints. PCIe, ATCA, optical I/O, and RAID are applications where vertical height restrictions on the backside of the board tend to manifest. Notice how when these regulators are replaced with ultra-thin modules, they can move to the backside of the board, hence recovering some topside area of the PCB. This benefit of ultra-thins is seen more dramatically in this quick animation. Moving point-of-load regulators from the top of the PCB to the bottom side frees up room on the top for more digital hardware, memory, larger FPGAs, additional connectors, or other features. Some digital devices like FPGAs or processors create so much heat they require a heatsink or a liquid cold plate. The heatsink or cold plate imposes a height restriction on components in the vicinity of the high-power digital ICs, which can translate into a loss of precious PCB real estate. In these applications, ultra-thins can excel. Since our ultra-thins are similar in height to high-power digital ICs, they can even share heatsink. The LTM4686 is a new member of our ultra-thin and PSM micromodule regulator families. It's a dual 10-amp step-down switching regulator, 12 amps peak. The module's outputs can be paralleled together to deliver up to 20 amps DC or 24 amps peak. The standalone supported input voltage range is from 4.5 volts to 17 volts, and the output voltage range is 0.5 to 3.6 volts. Step-down conversion from 2.375 volts input is possible when a 5-volt aux bias supply is available. You can generate 5-volt bias with a tiny charge pump. Multiple LTM4686 modules can be paralleled, easily scaling up for higher output power. Only input and output capacitors are needed. Here's a sample of the kind of voltage margining and telemetry supported by the LTM4686 via PM bus read and write commands. Module voltages, currents, and temperatures are digitized round-robin by a 16-bit delta sigma ADC, making new data available every 90 milliseconds. The LTM4686 supports focusing the digitization of some parameters like output voltage and current. for limited durations, making fresh readback data available as quickly as every 8 milliseconds. Here's our portfolio of PSM modules. The higher power LTM4676A and 4677 are pin compatible to each other. The LTM4675 and 4686 modules are pin compatible to each other and can drop into LTM4676A and 4677 layouts. All these modules provide best-in-class performance for DC-DC setpoint accuracy and telemetry readback accuracy. Of the modules shown, the LTM4686 is unique in featuring an ultra-thin profile. Our PSM modules come with factory default EEPROM settings, standard. Sometimes you need to configure a setting in EEPROM that's different than the factory default. We offer pre-programming and third-party programming options, but you can program the EEPROM yourself if you want to. And here's how easy it is. On your board, make sure to install a 4-pin programming header. We recommend a variety of connectors in our datasheet: surface mount, through-hole, keyed, non-keyed, right angle, and vertical. Plug the DC2086 powered programming adapter into your board. Then, plug the DC1613 USB to I2C dongle ribbon cable into the DC2086 and your computer USB port. Launch LT PowerPlay and work offline. Open your board's project file. Run the built-in custom script to wake up your devices. You'll see that the communications and programming is now possible. Go online. Click on the PC to RAM button. Then click the RAM to NVM button. And that's it! The EEPROMs are programmed. We provide a selector table of these products, datasheet, and other information on the website. For more information, please visit analog.com. Thank you for watching.